Hello all. Today we are going to discuss about the very important topic in physics, and these are the basic of physics, which talks about measurements and experimentation. Now when we discuss about the measurements in ancient times, there are a lot of pictures which comes in our mind. Here if you see, it's talking, Auntie, I'll give you a handful of rice and you give me a handful of corn. Okay, the auntie is saying somehow it doesn't seem fair. Okay, the other character says I stay at 84 paces from here. Now let's talk about some interesting facts related to measurements and experimentation. Now we all know the word yard. The yard is a different story. This measure of 3 feet or half fathom was decreed by King Henry I to be the distance from the tip of his nose to the end of his thumb. Then we had Alexander the Great conquered the world, and ancient measurements were carried to Greece and Rome as standards for foreign trade. The earliest measurements were based on parts of the human body like the hands, arms, and feet. Egypt was one of the earliest civilizations to develop standard measurements, but they were still based on parts of the human body, the cubit, span, and the palm. Measure your own cubit, span, and palm. After understanding the facts of the measurement, or the interesting facts of the measurement, let us study more in detail what is measurement. It is a process of comparing the given physical quantity with the known standard quantity of the same nature. Now, when we talk about the standard unit, you could see some of the points which you have to remember, which is given in the green box here. But what is physical quantity? It is basically numerical value into unit. And what is unit? It is the quantity of a constant magnitude which is used to measure the magnitudes of other quantities of the same nature. Now, when you are doing physics, the basic part which you all have to understand is the kind of units. And there are two types. One is fundamental, which is basic, and derived. Now for basic quantities or the base quantities, they cannot be defined in any other physical quantity. So let us take some of the base quantities. We name it as length, the symbol is L, SI unit meter, symbol is M. Base quantity mass, symbol M, SI unit is kg, that is kilogram, symbol is kg. Time, symbol is T, SI unit is second, denoted by small s. Temperature, symbol is capital T, SI unit is Kelvin, symbol capital K. And current, denoted by symbol capital I, SI unit of current is ampere and the symbol is capital A. Likewise, we have derived quantities. Now the quantities which are derived from the base quantities. Students, you have to understand that these base quantities are basically used in the derived quantities. Like volume, length into breadth into height. So now length, breadth and height is denoted by meter. So we have meter for breadth, meter for height. So it becomes cubic meter. For density, mass upon volume divided by volume. So we have mass, for mass we have kg, and unit for volume, as we have seen, it is cubic meter. So kg divided by cubic meter. So you will get kg meter to the power minus 3. For velocity, it is displacement upon time. So what is the unit for displacement? It's meter, which is divided by time, that is second. So you can also write meter per second, or you can write meter second to the power minus 1. It is same. Next, we have acceleration. So what is acceleration? Velocity upon time. Now, velocity, we all know what is the velocity. For the unit, we derived it right now, right? It is meter per second. So now meter per second is divided by what? Time. It becomes meter per second square. So either you write meter per second square or you write meter second to the power minus 2. It is right. Force, mass into acceleration. So what is the unit for mass? It's kg. See here, unit for mass is what? Kg. So kg we use for the derived quantity. For acceleration, it's what? Mass into acceleration. So what is the unit for acceleration? Meter per second square. Is that clear, student? So force is equal to mass into acceleration. Hope the slide is clear to you. Please remember, students, that before you start your concept for physics, it's very, very important to understand that what are base quantities and what are derived quantities. Now, to understand the systems of unit, we have CGS, we have FPS, and we have MKS. So what is the full form for MKS? It's meter, kilogram, second. And for CGS, we have centimeter, gram, second. For FPS, we have foot, pound, and second, which we rarely use it. Now, the different base quantities are being described here. That is for length, mass, and time. Now, very important part is for SI system, which is full form for SI system is System International. So, system of units. Here you have to understand the international system of unit, which we use it as SI. For K, it is Kelvin. For M, it's meter, so it's distance. For distance, we use meter. For electric current, it's ampere, as we have seen it in the previous slide, the symbols which are given. For second, the quantity is time. For amount of substance is mole, which you will be studying in higher grade related to mole concept. Then you have kilogram for mass, and then intensity of light is candela. So these are some of the important SI units which you have to remember. Now comes prefixes for measurements. Now, what are prefixes? Prefixes are used before the word. So for big measurements, for prefixes, if we see, we have deca, we have hecto, kilo, mega, and giga. Now, what are the symbols used for that? Deca, it's DA. For hecto, it's H. For kilo, it's K. For mega, it's capital M. And for giga, it's capital G. So what is the meaning for that? If it is given 1 deca, that means it's 10 to power 1. For hecto, it's 10 to power 2. For kilo, 10 to power 3. For mega, 10 to power 6. And for giga, 10 to power 9. So we saw for the big measurements. Now let's see for the small measurements. For small measurements, what do we use, student? We use the prefixes deci, centi, milli, micro, and nano. And please remember, these are the symbols which are given: small d, small c, small m, mu, that's micro, and nano, n. And likewise, they're also given the meaning for all these measurements. Okay, now it's the time to remember this. So there's no rote learning, no rote cramming. So we have a mnemonic to help you remember. Any guesses? Okay, let's go. So a mnemonic can help you with conversions within the metric system. So each letter of the mnemonic begins with the first letter of the metric prefix. I want to repeat this again, kids. Each letter of the mnemonic begins with the first letter of the metric prefix. So here, if you see, please remember this. That will help you to understand what is metric system and the conversions. King Henry died by drinking chocolate milk. Oh my. So let's see this. For king, we use kilo. Henry, hectare. Died, deca. If you want to replace any other word for T, it's fine. By its base, that is no prefix. Drinking, deci. Chocolate is centi and milk is milli. So kilo, hectare, deca. Base, that is no prefix. Deci, centi and milli. So I think it's easy for you to remember this. So let us try converting these now. Okay, 1 centimeter, I'll give you some time, is how many meter? You can refer from the previous slide and do this. So 1 centimeter, 10 to the power minus 2. Likewise, these are the units which are converted. Hey, it's a great job. Then we have unit of length. As we discussed in the previous slide for the SI unit, that is System International. So SI unit for a unit of length, it's meter. And what are the subunits? Centimeter, millimeter, micrometer, and nanometer. What are the multiple units of meter? Kilometer. For non-metric units, bigger units, we have astronomical unit, and there is a particular value for that, 1.496 into 10 to the power 11 meter. Oh, it's a big number. Light year, parsec. Then we have the smaller units. It's angstrom, 10 to the power minus 10 meter. Fermi, 10 to the power minus 15 meter. Okay, let's go further for units of mass. SI unit, kilogram, kg. Subunits of kilogram, gram, milligram, and multiple units of kg is quintal. And non-metric units also we have, students, which talks about bigger units, solar mass, smaller units, atomic mass unit. Likewise, for the multiple units again, we have metric ton. Now, when we say quintal, it is 100 kg. When we say metric ton, it is 10 quintal. Going further to understand units of time, SI unit is seconds. Subunits of second is millisecond, microsecond. We use it, which you'll do it for the higher grades, nanosecond. For bigger units of time, we have minute, hour, day, and lunar month. Then we have month, year, leap year, and decade. Century, millennium. Now comes the very important part, the guidelines for writing units. In symbols, if named after a scientist, you write the first letter in capital. Else you write it small letter. For example, we take M, S, kg, N, J, PA, Pascal, H, Z, and W. And what about words? The full name of the unit is always written in small letters, whether it is named after a scientist or it is not. So please remember this whenever we are talking about the symbols or we are talking about the words. Okay? So we write second, meter, kilogram, Newton, Pascal, joule, and hertz. There are also compound units. Multiplied units, that is if you put a dot or a cross or leave a space between the units. So like if we talk about Newton meter, then there are divided units. It is also expressed as negative powers, as while we were seeing in the previous slide that how you write down meter per second, or you write ms to the power minus 1. So please remember, students, there are no plurals in symbols. Okay, so when writing in short forms, plurals are not used. For example, 10 meters is not written as 10 ms, as ms means millisecond. So please remember this. It is extremely, extremely important where students tend to make mistakes. Single prefix, more than one prefix cannot be used at a time. For example, 10 to the power 9 watt, we may write 1 GW. So we cannot write 1 small kmw. That will be wrong. So this is right and this is wrong. Prefix and symbol. Prefix along with the symbol becomes the new unit. For example, we say km cube means 10 to the power 3 m cube. So 10 to the power 9 meter cube, not 10 to the power 3 meter cube. So this is very, very important. You have to take care while you are writing the units. Thank you so much, students. So now the next video will be on the measurement of length, but in detail, coming soon. So stay connected for more learning. Thank you. God bless you. And yes, extract some time to like, share, and subscribe. Thank you, and God bless you. Have a great week.